All right, Craig, so you're seeing my screen. Got a question for you to look at here. It says if t squared plus y squared I minus 9 times 14 minus 13i equals -6 minus 7i, where I is the square root of -1, what are the values of y which satisfy the given equation? Have you ever seen anything like this before?
No.
Never. Okay,
Well,
so this is
like, instead of like it wouldn't be completely blank. Like it wouldn't be like instead of y squared I, it would be like numbers.
okay, got it. So let me actually grab a different question and start with that one instead, and see see if you've got an understanding of how to do that. So just give me just a moment here to pull that up. That's part of this kind of first lesson, is I got to figure out what kind of stuff we can work on or not. So let me get there.
You have anything on your last month's worth of, this says Kuto software, infinite geometry is one of your things. Is that?
No, that's just like who made that paper.
Yeah, but he might know the makings of that. That must be a software company. Infinite geometry. This one's called classifying angles. So it sounds like that's what you've been doing, is some types of geometry. But I also saw you do something with these numbers and letters before too. Well, not like a month ago.
Complementary and supplementary angles.
This type of thing.
All right, I'm almost there. Apologies for the delay. I didn't have.
No problem.
This,
we're just trying to find a sweet spot so far too.
Yeah,
thing.
the idea is that some of these they call this heart of algebra, and if you haven't had algebra, or haven't taken all of it, it'll look completely foreign. But I got a question I posted last week that is probably more of a good starter question. So let me snip this in, and we'll take a look at this here. Let's see. So this one, Greg, we'll look at. We can always do some angle stuff, but let me just get this going here. All right. Okay, so here's your kind of starter question here. It says if x minus 9 equals -2y and y divided by 3 equals 2, what is the value of x minus y? So have you seen anything like this before?
Yeah.
Okay. Let's take a look at this first equation on the right here. How do you solve this for y, or can you just tell me the value of y?
6.
Y is 6. Now notice there's a second equation here. X minus 9 equals -2 times y. We're going to use this value of y in the equation here. So we're going to write x minus 9 equals -2 times 6. Okay. Do you know how to solve this equation?
I think so.
All right. Give that a try, please.
I got a scratch piece of paper and sketched it. So x would be -3.
X minus 9 equals -12, x equals -3. Good. And then what is the final answer? They want the question asks for x minus y.
So if y is 6, y equals 6, and x equals -3. -3 minus 6 is -9.
Very good.
So A.
Believe the answer, is A here. So let's try another version of this question here, but let's see if you can do it on your own here. I'm just going to go ahead and grab one that I like here. Oh, it's not in 2 column, is it? Look here. Okay, so now I see why. Okay, so let's look at another version of this question. Find a good one here. Okay. Okay, so this time I'm going to time you. And I like to do this because it helps to determine, whether you're going to be able to answer these questions quickly on a standardized test. So are you ready? We're going to do a timer on this one.
Okay.
All right, so I'm going to paste it in and I'll let you get started here.
Okay.
How are you doing on this one?
I'm very close.
Great.
I think I got it.
Okay, what is your answer here?
So I think y equals -16.
Okay, and x equals
-28.
okay. So what is your final answer for x minus y?
-44.
Is that one of the answers that's here?
No.
No, so that's not good. So let's take a look at it together here. So the first equation here, I agree, y is definitely -16. So when you write that next equation, you're negating, so there's a negative in front there, you're negating the value of y.
Yeah.
Okay, so that becomes 16. Now, what do you do to solve this equation?
You make x -4 because 2 negatives make a positive.
You do. Now, you actually subtract 12 from both sides. And maybe you haven't seen this before, and we're identifying a skill here. Now, do you see that there's a -1 in front of x?
Yep.
So you divide both sides by -1. So x equals -4.
Okay.
And that changes the answer because the answer is x minus y, -4 minus -16. -4 plus 16 equals 12.
Okay.
Okay, so let's deviate from this question slightly, and let me just go and pull up some other stuff that I think would be good here. This is a practice worksheet I use for students like yourself. Let me just grab it, and we will talk about how to do it. All right, here we go. All right, so let's say I asked you to solve this question, which I'm about to snip in here. All right, so this question says -44, forget about this 14 on the left. It says -44 equals -14 minus 3q. And you're being tasked to solve for q.
What?
Do you have any idea how you would do this? And what you're not supposed, here's what you're not supposed to do. You're not supposed to guess and check. You're supposed to use some math operations. And that's what I guess I'm trying to understand here, if you've seen those before.
Is would Q be 10?
Q is 10, but you're probably such a good math student, you probably could just look at it and tell me that's the right answer. Here's what I'm looking for, and this is where I want you to tell me if you've seen this before or not. Adding 14 to both sides. Have you seen that where you undo this right here?
Mm-hmm. Yes.
Now maybe you're so fast you can just do that without writing it down. And here you divide by -3. So yes, Q equals 10. All right. So you definitely know how to do that. Let me give you another problem here and see if you can tell me if this is something you've seen before.
You're used to that.
All right, so here's a new problem. The last two, these are solving two-step equations. I want you to solve for L in this problem. And
I'm
go ahead.
I'm just writing it down right now.
Got it. And my preference is for you to use it. And have you seen this before? The order of operations?
Yes.
You have. Okay. Do you recall that when you're simplifying, which is not what we're doing here, when you're simplifying, you go to the right. When you're solving, you go to the left. And I can explain what I mean by that, but this is very important in terms of how we're going to solve this question.
All right, so you want me to try and do it right now?
Yes, I'd like you to try and solve this, please.
Okay. For L or?
Yes, solve for L. How are you doing on this one?
Okay.
Let me know when you have a final answer.
Okay.
All right, so I'm going to jump in here, Craig. I'm going to just add 17 to both sides just to kind of let you see the steps here. Now on the right here, I gave you this in particular because I'm not sure how you would know to handle this. You can actually clear this thing right here by multiplying by -8 over 1. Have you seen that before?
So that would make it go away?
It does, yeah. This is the reciprocal of it.
And do you have to do anything? And
Well,
you have to do that to 6 as well?
Yeah, you have to. It's an equivalence thing. You do the same thing to both sides of the equation.
So it would become 48 because 48 over 1.
Yes, so 48 is what L is.
Okay, yeah, I've never seen that.
You've not seen this before. Okay, good. Well, we're getting into some stuff you said that you hadn't seen. So let me, you mentioned some stuff earlier in the day. If I give you an angle like this, and I tell you that this is 42 degrees, can you tell me what type of angle this is? Can you give me the name of it?
Like as a shape or like?
So there's, okay, so if I made this multiple choice, that's the problem is I have to give you the words now. There's a couple of angles that you might be asked to define. So one is an acute, one is obtuse, right, straight. These are
Yeah, that's acute because it's less than 90.
It's less than 90. What about obtuse? What is that?
Bigger than 90, so 91 and up.
Okay. How about a right angle?
Exactly 90 degrees.
How about a straight angle?
180 degrees.
All right, very good. So notice if I give you an angle like this, and I tell you that this is 210 degrees, what kind of angle is it?
Obtuse.
But what if this angle right here is, oh boy, what do we want to give that? Go 170. Well, so okay, let me just back off that. So yeah, that's correct. Now, are you solving equations like, let's say here, I give you a right angle like this, and I tell you that this angle right here is 3x minus 20 degrees, and this one right here is 6x minus 10 degrees. Have you seen problems like this where you have to solve for x and then, for example, determine the angles? Have you seen anything like that?
No, not yet. Or
Not
I
yet.
think I might be just about to learn that, but I haven't seen it yet.
Got it. Okay. So how about, you mentioned this also, you mentioned some vertical angles. So let's say we have two lines that intersect here. Let's say this is 49 degrees right here.
Yep.
What is X, what is Y, and what is Z? Can you tell me those angle measures?
I think so.
Okay.
So I know Y is also 49 degrees because it's vertical to.
I agree. I agree.
I think X is 98 degrees.
X right here.
Yep.
Okay. So the answer is that the two angles 49.
Oh, actually, can
Yes, you can adjust.
I think so. If the lines are 180. Or is each side 131? X and Z?
Yes, X is 131 degrees and Z is 131 degrees. Also, okay, good. Yeah, so here's what I'm hearing, and you, what I think is true is that you have seen how to solve what I'll call one-step equations, and I'll give you a couple examples of these. So one-step equations are like this: x minus 4 equals 3, 4x equals 12. We'll go x over 3 equals -4, and then x plus 3 equals 4. You probably know how to quickly solve all of these. Is that true?
Yes.
Okay. Could you give me the answer to each one here? Just looking at it, x equals.
Okay, so the first one. 7.
Okay, the next one, or whichever, you tell me which way you want to go.
Yeah, you can do the one below.
Okay, x
3.
equals 3.
That -16.
So here you're actually multiplying both sides by 3 to clear this division by 3.
Oh, so -12.
Yes.
So, and then the next one, 1.
Yes. Very good. Okay. Now, what I want to move us to, and I think this is where we're going to like maybe focus the rest of the time we spend today here, is we're going to work on some two-step equations. Okay. So there's 4 types of two-step equations that you will see forever and ever and ever in math. And the first one I call add then divide. Okay. So you literally do exactly what I just said. You add and then you divide. And the thing that I can't make you do is I can't actually make you put pencil to paper and do this. But what I would like to see you do is I'd like to literally see you add 5 to both sides of the equation, even if you can visualize the answer to be 8. And then I want you to show division by 4 on both sides of the equation. So this fraction bar is division. Maybe you've seen that before, but this is how we do it as you progress further into math. Okay, so have you seen questions like this before in your math class?
Yep.
Okay, would you mind just replicating what I just did for this other question over here?
Sure. Okay, so x would be 4.
So yeah, I'm going to add 6 to both sides. 8x equals 32. Divide by 8, divide by 8, x equals 4. So have you heard when your instructors say they want you to show work for your problems that you're working on? Have you seen that?
Yeah.
Okay, so at a minimum, what I would recommend is showing, actually I'll highlight it. Make that bigger. So what I would recommend, sorry, I'm trying to grab the highlighting tool. There it is you for sure need to show the first line, this line, and then the last line. You have to for sure show those. Anything else kind of up to the instructor, whether they want to do that. So we started out with doing we did some problems where you had to actually solve some equations. So let's go back to those.
Okay.
So this question that I'm about to present, it's actually 3 questions in one. The first thing is you have to solve a one-step equation. So this is the one-step equation that you have to solve. Can you give me the value of y?
-20.
Very good. The second thing is you end up having to solve a two-step equation.
Which is the one right to the left.
Yeah, with sort of the added thing that you have to substitute in that number you just found. Now, how is your multiplication without help? Are you able to do this by hand? This on the right?
11 times -20?
Yes.
Yeah, yes.
Good. So that's -220. So this type of two-step equation you solve by subtracting and then dividing.
Mm-hmm.
Now, how's your division here? This is a tough one.
Wait, but how did you get 11 times 20? Wait, can you go up a little? Could you go up a little?
Sure.
Okay.
Sorry, I didn't, I went a little too fast there. Yeah,
It's
I'm rewriting this equation. And then I'm putting that value in for y.
Oh, okay.
That's why I was asking how your multiplication is, because you do have to figure out that number.
Okay.
So you subtract 1 from both sides. Do you see that?
Mm-hmm.
And then you're left with this division. Okay. Now what you should know is 13 times 10 is 130. And that leaves 91 left over. So 13 times, and you got to guess here, but 7 times 3 gets you the 21. And that tells you the answer is 17.
Nice.
Okay, but that's not the final part. The third part is to actually evaluate x minus y, which is 17 minus a minus 20.
Minus -20.
Yes, so it ends up, you add them together to get 37.
Good.
Okay, let me have you try one more here.
Would you add them together because there were 2 minuses in a row?
Yes, exactly. Yes, exactly.
Okay. If they're if there are 2 minuses next to each other and there's no parentheses, same thing.
Yes, so here's what you're asking me, and I'm gonna formalize this. 4 minus a minus 3 is the same as 4 plus 3. Now, as a student, what I used to do, and I think this is the right approach until you're really comfortable with this, is I would change plus plus like that, and then write 7. I wouldn't write this step. I would just immediately go there.
Okay.
And similarly, though, I mean, there's a bunch of questions I could ask you. It's like, what is minus 4 minus a minus 3? Well, it's minus 4 plus 3.
So -1.
Yeah. If it's in parentheses, the reason the parentheses here is because this thing needs to operate on it. And of course, it could also be 4 minus a minus 3 is 4 plus 3 also.
Okay.
All right. Okay. Let's try this problem here. This is probably the last problem for today. So I want you to first solve this for y. Let me know your value of y.
Okay. -12.
Yep. And then we write the other equation, but instead of y, I'm going to put in -12.
Okay. And okay, got it. So
what is 7 times 12?
So 70 plus 14, 80, -84.
Good. You subtract 4 from both sides.
Oh, one sec.
Yep.
So x has got to be a -11.
Very good. And then we go back to the original problem. X minus y, x is -11 minus a minus 12. That's what you were asking me about earlier.
So 11 plus 12.
Minus 11 plus 12. Yes, it is 1. Perfect. Right. Is your dad there?
I think he took a business call in the other room.
Okay. This is probably going to take us to the end of our
He
lessons.
just got back.
Oh, good. Rick, are
I
you
just had to take a quick phone call. What happened?
Oh, no problem. This is kind of the stopping point for the introductory, lesson, just to kind of, you guys get a feel for what I do. I can get a feel for Craig. If you'd like, I can give you some feedback right now about him or about the lesson.
Yeah, how far did you, I mean, I know it's hard to feel in the dark, you know, not even seeing what he had. I know he just mentioned classifying angles or whatever you've just been working on. So I knew you're kind of just feeling out where he's at. So
Yeah.
where do you think that landed?
Well, he's a very good math student for relative to his peers. And one of the things that's probably happening in the classroom is they're spending a lot of time explaining things that he gets very quickly. And they probably spend a lot of time, addressing questions students have, and he doesn't have them.
No, I wish they did, but to be honest with you, and you speak up, Craig, at least he told me that the math teacher just puts things up, and that's actually why he actually wanted to do extra help, because
Interesting.
even though he was getting A's, he felt the instruction wasn't detailed enough. And then when he raised his hand, the teacher was like, hey, this is the advanced program. If you're not getting it, you might get left behind, or some snarky thing,
I see. So
is that correct, Craig?
Yeah, and in the beginning of the school year, I was sick and I was out for a week or so. And when I got back, I was confused and I had a couple questions, and he was like, and he had this whole like talk and like lecture.
He was just a little sharp. Is he sharp with all the kids? I want to be fair, but I mean, was it, because it was, of course, it's the end of the pandemic. He was sick, misses 4 days. And then he's like, hey, maybe you need to drop down to the other one. Maybe you can't keep up with these kids. And I'm like,
I see.
So then we ended up having a meeting, and I said, I think he just wants some clarification. And he doesn't go to a school that has, how many kids are in your math class? You don't have 30 kids or anything.
Like 15
Yes.
in honors, and probably like.
So my thought was, it's a little bit disappointing, to be frank, is that,
sure. Yeah,
that with 15 kids, if one kid or two kids have a question, that he'd say, okay, I can spend a couple of minutes with you on that, or what have you. So anyway, that, just wanted to point that out, that he's not spending time on that. He's kind of, I don't know if he's phoning it in, but he's just telling him to do it.
Well, yeah. So Craig mentioned, he asked me about this. He said 4 minus, and this is a very simple thing, but it's exactly what you're mentioning. He said, well, and I don't remember exactly how you said it, Craig, but the answer here is 7. But there's like a lot of things that go into this, which is like that these cancel out. You can either write it this way, or you can write it this way, or you can even write it this way, I suppose, this way. And I think, like you said, he wants, and you tell me if you're wrong here, Craig, but I think you want kind of like, you want to know why this is the case, because you're going to see something more complicated later. And I think you want to shore up like your understanding of these kind of like things you're seeing in the classroom. And you maybe say, well, why is that? And is that kind of the question you're asking yourself and what you're looking for to shore up?
Yeah, I thought it was that, but I just didn't know parentheses really made a difference.
Right. And that's what I'm saying, is like you maybe want to go ask your like, well, hey, does it matter whether the parentheses are there or not? And this is a very simple, I'm not suggesting you don't understand this. I'm suggesting that like you wanted clarity on like some sort of thing like this, and you're not getting that answered in the classroom, is what I heard.
All right.
Is that right? Okay. And there's probably other things like that. Like you're probably, if you're dealing with angles, because you started talking about shapes, like why is this an acute triangle and why is this, an obtuse triangle, or, because there's an acute angle or something. Like maybe you have other questions like that you need specifically answered that aren't being addressed in the classroom. Is that
yeah.
Okay. So what I've told other students, and if you can think to do this in the moment, is just write it down in your notebook. Because your dad's right. I mean, you're not getting a lot of support from the teacher, but if you think to write those down, we can cover those. I can answer those questions for you and give you the why, like try to justify and give you like more examples. So we were talking about 4 minus a minus 3, but in a future problem, you're going to see 4x minus a minus 3x, and you need to know that that's 7x. And that's what I mean by like, if you have a question on this, it leads to this, and then this right here is in some other problem with other stuff going on the left and the right. So we've got to shore that up to make it clear for you.
Can we do one more problem?
Sure.
Okay.
You mean like this, or you want some other? Do you have something specifically you want to send me?
Just like a problem like the ones we've been doing.
Oh, like these. Well, let me show you. Talk to your dad here a bit about what we're doing. So these are. I post a question of the week to my website every week, and it's meant as test prep. So for your son, depending on the question, he may like know how to do it right away, or he may be able to work his way through it. But this is what I had in mind when we had talked is working on this kind of stuff. They're multiple choice. They're designed with like several steps that you see when you look at standardized tests. Like there's more than just one thing to do. You have to first solve for y, then use the y to solve for x, then use both those values here. And this is what I was suggesting that we work on in some of these sessions, as well as
Now, when you started with that or at the beginning of the session, was that already too advanced, or you guys can get there fairly soon?
so the all of this together is too advanced, but he knows how to do this, and he knows how to do this, and he knows how to do this. So if he works on this process, and I'll send you guys a copy of this worksheet, which has got 10 problems in it, he can get really fast at it. So the goal is to get these done in 60 seconds or less. Do you remember when I timed you, Craig, for
Yeah.
You did it in about 80 seconds, and we want to get you under 60 for all of these. And so the practice is what's going to help you get there. Like when you know to do 1, 2, and 3, you're going to get this down to 30 seconds, I'm guessing. If you and that, so to answer your question, Rick, it was like, well, he knows how to do all the individual pieces, but the synthesis of it is the challenge. That's where most students struggle with the standardized test, because in the classroom, this is part A, this is part B, and this is part C, and they have to know to do all this together.
Yeah, I mean, I'm even questioning. And that's probably no help. Why would A be the second thing and B be the first thing, and then C is back to the third thing?
Because these tests are written to distract, disguise. They're designed to be disruptive to your thinking. They're not linear. They're not linear.
Yeah.
It's because this one A, you can actually figure out what Y is, but if you don't already know what Y is, then B, you won't be able to do it. That's why you would do this.
He's exactly right. Yeah.
Okay.
So what I would recommend, and we should probably talk a little bit more about this at another time, Rick, is if we were going to do anything together, it would be a combination of like some of this test prep stuff, and then if he's got individual questions, from class, I can answer those and kind of explain more detail on that.
Okay, great. And I know we probably got interrupted. You were mentioning how you felt. You said he did pretty good, and then somehow we got interrupted. How else did you feel he was at?
I think he's very strong in what I would call number sense, which is like multiplying, dividing, adding, and speed. Like he's really fast. He doesn't have questions about what to do when there's a negative with a negative or negative and a positive, things that are stumbling blocks for young students. So that's really what I would do, is even just impress upon him to do even more of that. Like if you guys are out to eat, like ask him to figure out the tip. Ask him, say, okay, we just drove I don't know, 10 miles in 5 minutes. How fast were you going? That's, it's really fast, but I would really challenge him with stuff that you see, in regular life, and just like when you go to the store and say, okay, this is 128 ounces for $3. This one's, 96 ounces for $2.50, which is the better buy. I would keep like pushing him to do this, what I call number sense, which is just this kind of computational stuff that you need to do on the fly, and see how he's doing with it. Because I think you'll find he's really, really good and really fast at it. So let me just finish up this problem here. I'm going to send you a copy of the notes and the screen recording from today. And then we'll, maybe Rick, you and I can talk offline.
Oh, I'm sorry, Matthew,
You're dropping out here. Let me know when you're back. Hey guys, you
Hello?
back? Hey,
Okay, we're back right
It's
now.
Cutting off.
Yeah, we have you drop twice.
no problem. Yeah, I see that here. I was just gonna suggest, Rick, you and I could talk offline, maybe the next few days, and kind of decide what you guys want to do. But this is the format. This is what you can expect for the lessons, and if you like it, I hope you like it. We can certainly do more of this.
It seems fantastic. He leaves tomorrow morning and he'll be gone on a science trip down in the Florida Keys doing what is that called? Marine biology.
Marine science.
Marine science. And so he'll be gone for a while until next week, really.
Okay.
So then when he comes back, then we'll see if we start getting things settled. I think at that point his mom might be back in town and he might be staying with his mom at that point. So there's a little bit of a juggling act, but when we start getting things online, we'll be able to figure out a real schedule on that.
Sounds good.
Anything else we need to know as well?
No, not at this time. I'll send you an email here shortly with just the follow-up from the lesson today. And I'll just communicate with you in the next, week or less.
Perfect. I just wanted to know if you didn't hear in the next certain amount of days that he's actually out of town and
that sounds great.
Trip.
That's awesome.
Yeah, it's gonna,
Hope you have
it
a
should
good
be
time.
amazing. I couldn't imagine doing it when I was in 6th grade.
Yeah, that's great. All right, guys. Well, have a great day.
Hey, thank you so much. We'll talk to you soon.
Thank you.
You're welcome. Bye now.